This little clip is going to show us Boyles Law. And as we covered in the notes, Boyle didn't boil, so he keeps the temperature of the gas same. As the pressure on the gas increases, the volume or the space it takes up decreases. And the opposite is true, is the pressure decreases, the volume or the space the gas takes up increases.
Boyle's law states that in a closed system, pressure and volume are inversely proportional. What that means is that as pressure increases, volume would decrease and vice versa.
The only equipment you can need this episode includes a large syringe that you can get at a medical supply store or drugstore,
and water balloons, which we found to work well because of their small size. Although we're not dealing with anything hazardous in this episode, it's never a bad idea to wear some eye protection and a lab coat or apron. The first step in our experiment is to blow up our water balloon. Keep in mind how large it is, as it still has to fit inside the syringe. Once you have it to a good size, just tie it off, like so, and you're ready to go.
The next step in our experiment is take your small balloon in your large syringe and drop the balloon inside the syringe and place the plunger on the end. For our first test, place the plunger at the highest.
Now, right now, the pressure on the balloon is the same as the outside air pressure, so nothing's changed. He's going to increase the pressure on the gas by pushing down on the plunger of the syringe. When he does that, the gas inside the syringe, as the pressure increases, the volume or the space it takes up will decrease.
Point in the syringe and cover the bottom opening with your finger. Next, press the plunger down and watch as the balloon shrinks.
So two things happened here. One, he increased the pressure by pushing on it, and that decreased the volume of the actual space that the air inside the syringe took up. Because this air is under higher pressure, it's also pushing on the balloon harder, and you can see the evidence of the higher pressure because the volume of the balloon also decreased.
In size. Remove your finger from the bottom of the syringe to release the pressure. For the second test of our experiment, we're going to place the plunger at the lowest point it can be without touching the balloon. Once again, place your finger over the opening in the bottom of the syringe and pull the plunger upwards. Watch as the balloon.
By doing that, he's increasing the volume, which means he's decreasing the air pressure inside the syringe, and the air pressure inside the balloon is staying the same. So because there's less pressure on the outside and the same pressure on the inside, the balloon is expanding.
The balloon increases in size. To release the pressure, remove your finger from the opening in the syringe. Let's look at this experiment a little closer. Boyle's gas law states that when a fixed amount or mass of an ideal gas is kept at a constant temperature and in a closed system, then its pressure and volume are inversely proportional. What this means is, when pressure increases, volume decreases, and as pressure decreases, volume increases. An ideal gas.
So they're going to apply the pressure by pushing on the top of this syringe.
Gas is a theoretical gas composed of a set of randomly moving, non-interacting particles. Under normal conditions, many gases such as oxygen, hydrogen, and some heavier gases like carbon dioxide will behave like an ideal gas. This means they follow the laws of ideal gases, such as Boyle's law. In our experiment, the balloon and syringe are filled with tons of gaseous air molecules. Placing your finger over the opening at the bottom of the syringe keeps the mass of air molecules constant and creates a closed system that will allow us to manipulate the pressure and volume. When we press the plunger down, we are increasing the pressure being placed on the air molecules inside the syringe by reducing its volume. As the pressure increases, the amount of force placed on our air molecules increases, and they are forced closer and closer together, decreasing the volume of space that our gas takes up and shrinking the size of our balloon. When we remove our finger from the bottom of the syringe, we release the added pressure and our balloon grows back to its original volume. In the second portion of our experiment, we start with the plunger at the bottom of our syringe, almost touching the balloon. When the plunger is pulled upwards, we are reducing the pressure inside the syringe by increasing the volume of space the air inside takes up. This decrease in pressure and increase in volume pulls the air molecules further apart, increasing the amount of space the gas takes up, growing and expanding the size of our balloon. Removing your finger from the bottom of the syringe returns the pressure back to normal, reducing the volume and size of our balloon. When we compare the two variations of this experiment side by side, we can clearly see the inversely proportional relationship between the volume and pressure of an ideal gas. This relationship is known as Boyle's Law.